Alright, Chapter 3 Summary. The chapter presented information for the character of the transmission line, information followed with the sum of the important points of the chapter. Transmission line, the device guiding electrical energy from one point to another. Input independency, the ratio of the voltage current of the input of the end of the transmission line. Output impedancy, ratio of the voltage current of the output of the end of the line. Two-wire open line with the parallel line with the SU for the power lines. Roll telephone line with the telegraph lines. The type of line has high radiation along with the subject of noise pickup. Twin lead with the parallel lines, most often used with the connection of the televisions and antenna. Twisted pair with the two insulated with the twisted pair together the line with a higher insulation along with the shielded pair with the parallel conductors separated solid dielectrical surrounding the copper braid tubing the conduction or valence grade. Rigid coaxial contained the two concentric conductors insulated from each of the other with a spacer. Some rigid coaxial lines are pressurized with the in-air gas to prevent moisture and entering the high frequency loss with it, and then the other lines. Flexible coaxial lines consist of the flexible inner conductor with the concentric outer conductive metal braid. There are two separated with the continuous insulating materials. Waveguides are how the metal tubes and transfer energy one point to another with this energy travels slower. The waveguide in the free space. Cylindrical or rectangular copper loft with the result of the amp squared over the resistance loss with the form of the heat and skin effect with the loss decrease with the conductivity of the time. Dielectrical loss caused by the heating of the dielectrical material between the conductors taking power from the source. Radiation induction loss caused by part of the electromagnetic field of the conductor being dissipated into space near objects. Transmission lines either long or short. Physical length is not equal to 1/4 length of the frequency that is to carry. Lumped constant the theoretical properties, inductive resistance, capacity of the transmission line with lumped into a single component. Transition and the distributed constants, the constant of the inductive capacity, resistance are distributed along with the transmission line, and inductancy, capacity, resistance. Leak currents flow from the wires of the transmission line with leak through the dielectrical axis resistor. Electromagnetic field exists in the transmission line with a current flow through it, and also the electric field, magnetic field is dotted. Characteristic impedance is ZO, the ratio of the voltage over the amps is every point along the line for the maximum transfer of the electrical power. Character of the impedance load impedance must be matched. Velocity, which the wave travels over the given length of the transmission, can be found with using the formula. Velocity is equal to the distance over the square root of the inductance and capacity. The transmission line is not permitted. The character of the impedance is to said be finite. When the DC is applied to an open-ended line, the voltage is reflected back from the open end without any change of the polarity, amplitude, shape. The current is reflected on the same amplitude, shape, of the opposite of the polarity. When the DC is applied with a short circuit, the line with the circuit is reflected back to the same amplitude of the polarity. The voltage is reflected back with the same amplitude of the opposite polarity. The AC is applied with the open-ended line. Voltage is always reflected back into the phase of the incident wave. The current is reflected back out of the phase. Alright, so the voltage that would have continued on had the line been longer. Incident wave of the moving to the right, the resultant wave, reflected wave moves to the left, sending a wave that when the AC of the short circuit of the voltage is reflected with the opposite phase, the current is rectified in the phase. Reflections in the phase, reflection out of phase. Okay, voltage and current. A non-resonant has no standing wave with the current voltage, either the infinite long or terminated the characteristic of the impedance. Resonant and standing line has a standing wave. The current voltage of it is finite length and is not terminated with the character of the impedance. Open-ended resonant line at all odds, 1/4 points of the voltage is minimum. The current is maximum, and the impedance is minimum. At all 1/4 points of the voltage is maximum, and the current is minimum, and the impedance is maximum. All even, sorry. There are variety of the termination of the radio frequency line. Each termination has an effect of the standing waves over the line. Inductive capacity, character of the impedance, the inductive reactancy, character of the impedancy, resistance of the character of the impedancy, resistance less than the character of the impedancy. Transmission line terminated with the character of the impedancy. Open short circuit with the capacity of the inductancy. When the termination of the transmission line is not equal to the character of the impedancy, there is no reflection on the line. The amount of the voltage may be found by using the following formula. Voltage of the reflectancy of the equal to the voltage of the incident is equal to the resistance of the inductancy minus the character of the impedancy over the resistance inductancy plus the character of the impedancy. When the termination of the transmission line equals the character of the impedancy, there is no reflected voltage. This measurement of the standing wave of the transmission line reveals the information on the operating conditions. There is no standing wave. The determination for the top line is correct. The maximum power transfer takes place. All right, standing wave ratio. The maximum, measuring the maximum voltage current, the minimum voltage of the current with the transmission line with the measure of the perfection of the termination of the line. A ratio of 1 to 1 described the line terminated with the character of the impedancy. And that was chapter 3's summary.